Hello, aspiring test masters. Welcome to the second part of our interview prep series. In this installment, we'll delve deeper into the world of manual and automation testing. Our focus will be on common interview questions, providing you with the knowledge and confidence to ace your next interview. Let's get started. Manual testing forms the foundation of software quality assurance. It's about exploring the application, uncovering hidden glitches, and ensuring a smooth user experience. Let's explore some key concepts and practices. Imagine you receive a gift. It's beautifully wrapped, and you have no idea what's inside. In black box testing, you interact with it like any user would, unaware of its inner workings. You press buttons, swipe screens, and navigate through the interface, just like any end user would do. You're testing its functionality based on its outward behavior. You check if it performs the tasks it's supposed to without knowing how it achieves those tasks internally. Conversely, white box testing is like having an X-ray vision of the gift. You can see through the wrapping paper and understand exactly what's inside before you even open it. You can see the internal components, the code, and understand how they interact. This insight allows you to test not just the functionality, but also the structure and flow of the software. This allows you to test the software's internal workings directly. You can identify potential issues in the code, optimize performance, and ensure that every part of the system works as intended. This comprehensive approach helps in creating robust and reliable software. Agile methodologies are all about iterative development and rapid releases. Testing in Agile is integrated throughout the development process, not just at the end. This means testers are involved from the get-go, collaborating closely with developers and product owners. Boundary value analysis, or BVA, is an essential technique in software testing, particularly useful for identifying potential errors. Imagine, for instance, testing a field that accepts numbers from 1 to 100. You need to ensure that the system handles all possible inputs correctly. BVA focuses on the boundaries, the critical points where errors are most likely to occur. So, what happens when you input 0, 1, 100, and 101? These values are at the edges of the acceptable range. This technique helps uncover errors at the edges of input domains, ensuring that the system behaves as expected even at its limits. By focusing on these boundary values, testers can identify and fix issues that might otherwise go unnoticed. Equivalence partitioning is another effective testing method used in software testing to reduce the number of test cases. Instead of testing every possible value, equivalence partitioning groups similar inputs together into partitions or classes. This helps in identifying representative values that can be tested. For instance, if an input field accepts ages from 18 to 65, you could group inputs into valid, which is 18 to 65, and invalid, which is below 18 and above 65. This way, you don't need to test every single age. You then select representative values from each group for testing. By doing this, you ensure that each partition is adequately tested, which increases the efficiency and effectiveness of your testing process. This method is particularly useful when dealing with large sets of input data, as it simplifies the testing process and ensures comprehensive coverage. Setting up your testing playground is crucial for accurate results. A test environment is a controlled setup where you execute test cases. This typically involves configuring hardware, software, and data to mimic the production environment. Having a dedicated test environment ensures accurate and reliable test results. The importance of test coverage cannot be overstated. Test coverage measures how much of your application is being tested. It's like a safety net, ensuring that you're not leaving critical areas untested. Aiming for high test coverage increases the probability of finding defects. The life cycle of a defect or bug is a fascinating journey. A bug goes through a life cycle from discovery to resolution. Understanding this life cycle from new to verified to closed is crucial for effective bug tracking and communication. Let's talk about test cases and test scenarios. A test case is a set of specific actions and expected results designed to verify a particular feature. A test scenario is a broader description of a user's interaction with the software, often encompassing multiple test cases. Ad hoc testing is like exploring a new city without a map. It's unstructured and exploratory, allowing you to uncover unexpected issues that scripted tests might miss. While valuable, it's most effective when combined with structured testing methods. Not all features are created equal. Risk-based testing prioritizes testing efforts based on the likelihood and impact of potential defects. High-risk features receive more thorough testing. Automation testing is like having a tireless assistant capable of executing repetitive tests with speed and precision. Let's explore key concepts in Selenium Java, a powerful tool for automating web applications. ###3.1 Launching your browser with Selenium WebDriver. Selenium WebDriver acts as a bridge between your test scripts and the web browser. You can launch different browsers like Chrome, Firefox, or Edge using WebDriver instances. Each browser has its own WebDriver implementation. ###3.2 Taming dropdowns with Selenium. Dropdowns are common web elements. Selenium provides the select class to interact with them. You can select options by visible text, value, or index. ###3.3 Data-driven testing in Selenium. Why write the same test script multiple times with different data? Data-driven testing allows you to execute the same test logic with varying inputs. You can store data in external files like Excel sheets and feed them into your test scripts. 3.4 Juggling multiple windows. Modern web applications often open new windows or tabs. Selenium provides methods to switch between these windows, allowing you to interact with elements on specific windows. 3.5 Actions Class Mastering Advanced User Interactions. The Actions class in Selenium enables you to simulate complex user interactions like mouse movements, drag and drop, and right clicks. This is essential for testing intricate user flows. Visual evidence is invaluable when reporting bugs. Selenium allows you to capture screenshots during test execution. These screenshots serve as proof of failure and aid developers in identifying the root cause. All right, let's talk about organizing your code. As your test suite grows, maintaining organization becomes crucial. The Page Object Model, or POM for short, promotes code reusability and maintainability by separating test scripts from page element locators. This way your code stays clean and manageable. 3.8 Navigating frames in Selenium. Frames are like windows within a window. Selenium allows you to switch between frames using their names, IDs, or index, enabling you to interact with elements within specific frames. 3.9 Synchronization using weights. Web applications are dynamic. Elements might take time to load or disappear. Selenium provides explicit and implicit weights to handle these timing issues, ensuring that your scripts don't fail due to synchronization problems. 3.10 Test-ng annotations, adding structure to your tests. Testing is a powerful testing framework. Annotations like @test, @beforetest, and @aftertest provide structure and control over your test execution flow. They determine the order of test execution and set up or tear down procedures. Conclusion. Congratulations on completing Part 2. You've gained valuable insights into the world of manual and automation testing. Remember, mastering both is key to a successful career in software testing. By combining the exploratory power of manual testing with the efficiency of automation, you'll be well equipped to tackle the challenges of ensuring software quality.